All right, today we're talking about geometric sequences, but they're going to be defined explicitly. So our objective is to write explicit rules for geometric sequences. So first, the difference between a recursive rule versus an explicit rule. So a recursive rule always has to give the first term. Okay, so like f of 1 equals what? Okay, and then it's defined based on previous terms. Meaning, to find the second term, I need to know what the first term is. So it's going to be in terms of the first term. So the first term times 3, so forth and so on. It has that f of n minus 1, which we use to represent the previous term, f of n minus 1. Whereas an explicit rule is way more useful because it is defined by the number of the term, not by the previous one. So meaning if I want to find the third term, f of 3, it's going to be defined by a 3 in there. F of n is going to equal something with just an n in it. It's defined by, so let's say I take 3 times whatever term it is, or 5 times whatever term it is. It's defined by the number of the term. So meaning if I want to find the 10th term, I just input the number 10 and it'll tell me what the 10th term is. It's much more useful in finding higher number terms. For example, if I want to find the 100th term, I just plug a 100 in. For a recursive rule, if I want to find the 100th term, I need to know the first 99 terms to find the 100th term. You see, like I have to find all 100 of them to be able to find the 100th term. Whereas this other one, I just need to plug in a 100 and find the 100th term. Okay, so here Karen shares a funny video on social media. The video is viewed 10 times that day. Each day during the rest of the week, the video gets 3 times the number of views. So as it did the day. So 3 times the number of views as it did the day before. So on day 1, it got 10 views. On day 2, it got 3 times the number of views. So 10 times 3, that would be 30. We're multiplying by 3 each time. On the third day, 30 times 3, that would be 90, so forth and so on. So we can tell here, so it says, what are the first 3 terms of the geometric sequence? Well, we found them, 10, 30, and 90. What is the common ratio? We're multiplying by 3 each time. The common ratio is 3 because we multiply by 3 each time. And 30, if I take this 30 divided by the 10, the 30 divided by 10 is 3, 90 divided by 30 is 3, so forth and so on. Now it says, create a table that shows the number of views for the 4th, 5th, and 6th days. So we're going to go ahead and take this and we're just going to extend it out. So 4th, 90 times 3 would be what, 270? 270 times 3. Let me get my calculator out. So we've got 90 times 3 is 270 times 3 is 810. I don't want it like that. So let's go split view, left split. Okay. So 270, then we have 810. And then the 6th, we'll multiply by 3 again, 2,430. Wow, that video is blowing up. So, and then we need the 7th times 3 again, 7,290 views. Okay, so create a table that shows the number of views for the 4th, 5th, 6th, 7th days. Now we want to write an expression for the number of views on the nth day. We're going to do this 2 different ways. Okay, one is we notice this is exponential. This is exponential. So since it's exponential, that would be a times b to the x, right? Exponential is a times b to the x. And my common ratio is 3. I'm multiplying by 3 each time. So I know, since I'm multiplying by 3 each time, I know my b is 3. 3 to the x. Okay, but we can't just use here this first term of 10 for A because A comes from the 0th term, from term 0. So I'm going to have to back this up 1 and find out what the 0 term is. A 0 term doesn't really make sense in a sequence, but we need it to write the equation. So if I multiply by 3 each time, to go backwards this way, I'm going to have to divide by 3. So if I take 10 divided by 3, I get 10/3. So my expression for my sequence, they said to use up here, they say to use V of n equals, so V of n equals 10/3 times 3 to the n. So this 3, again, comes from that common ratio. And this 10 to the 3rd comes from the 0 term. Okay, and then I always like to double check to make sure this works. So I'm bringing my calculator. Okay, let's bring in my calculator. And so if I take 10/3 times 3 to the 1st power, I should get 10. I do. Let's see, did it work for the 5th term? If I take 10/3 times 3 to the 5th, 8, 10. It did. So it seems to work for this one. So this is one way of doing this problem. It's to back up to the 0th term and use that for A. Okay. Another way of doing it is to back up these number of terms and to back it up to the previous term and back it up here instead. So the other way of doing it, I'm going to switch colors. The other way is to still use the 10 for the 1st term. So V of n equals 10 times, but instead of doing 3 to the n, we're going to back it up 1. 3 to the n minus 1. So what's different here is instead of using the 0 term here we use the 1st term. So this guy right here is the 1st term. And then we do the previous term in the exponent. 3 to the n minus 1. Meaning, if I want to find the 6th term, I take 10 times 3 to the 6 minus 1, which would be 10 times 3 to the 5th. So to find the 6th term, I take 10 times 3 to the 6 minus 1. So that would be the 6th term. That gives me the 2,430. Okay, which still gives me the 2,430. So this is 2 different ways. I will tell you that your book always does it this way. This is the way the book does it. This is the book's way. This is Mrs. Neal's way because I know how to write exponential functions from our past so many sections, and so I'm better at doing it this way, and it's one less thing to remember. I often don't remember this n minus 1 hack, but I do know that this A term normally always comes from the 0th term, like what we did all last chapter.